Flying amongst the clouds is literally one of my favorite things in the world, especially when you're landing, going to a new destination. There's literally no better feeling than feeling like a bird, a plane, an eagle going to starting a new adventure. This is a classic video of mine, and the reason why I love sitting in the window seat, because it's unworldly and something that you only get for precious seconds on a plane if it's cloudy. And so today we're going to be looking at angle of elevation and depression, and you'll see why I chose landing as the video for today. So today we'll be looking at angles of elevation and depression and solve problems involving angles of elevation and depression. So the angle of elevation is the angle formed by the horizontal line and a line of sight to a point above the line. So basically, if the slanted line is above the horizontal line, we tend to dash the horizontal line. So if the slanted line is above it, then it's angle of elevation. And if the slanted line is below it, it's angle of depression. And the angle of depression is the angle formed by a horizontal line and a line of sight to a point below the line. So when you're like elevated and excited, you kind of lift your head up. And when you're depressed, you kind of bring your head down. So depression, the line of sight is down from horizontal. Elevation, the line of sight is above horizontal. So since horizontal lines are parallel, in this picture, angle 1 is congruent to angle 2 by alternate interior angles theorem. Therefore, the angle of elevation from one point is congruent to the angle of depression of another point. Okay? But like this angle right here might be different than angle 1, and this angle right here might be different than angle 2. So let's classify whether an angle is angle of elevation or depression. So angle 1, it's a angle of depression because the slanted line is below the dotted line. It's an angle of depression. Now try angles 2, 3, and 4. Angle 2 is an angle of elevation because the slanted line is above. The guy is looking up to see the top of the tree. And then angle 4 is also an angle of elevation because the slanted line is above the dashed horizontal line. Just in case you're wondering, angle 3 is an angle of depression because it's going down. The guy has to look down to see the bottom of the tree. All right, so we are going to have 3 more example problems. And it starts off by finding distance using angles of elevation. So the Seattle Space Needle casts a 67-meter shadow. If the angle of elevation from the tip of the shadow to the top of the Space Needle is 70 degrees, how tall is the Space Needle? So a key thing with these problems is going to be being able to draw them out. So this being 67 meters being the length of the shadow, y being the height of the Space Needle. If you want to, you can kind of draw a Space Needle out. I'm not even going to attempt it because that would just look horrible. So we need to figure out y. And guess what? We're in the trig unit, so we need to use our trig skills to solve for y. So we know the opposite side and the adjacent side. Tan uses opposite over adjacent, so we're going to use tangent 70 equals y over 67. And then solve for y. Well, y is already in the numerator, so we don't need to touch y, but divided by 67 is in its way. So we're going to multiply 67 on both sides so that y equals 67 times tangent 70. And then we put this into our calculators. And we get that it's approximately 184 meters tall. So if you wanted to write a complete sentence, you could say that the Seattle Space Needle is 184 meters tall. So take a look at this picture. This will kind of give you an idea of what's going on. We have two guys here that are surveying how deep this crevasse or crevice is to figure out how far it is to cross it. Okay? So this next one, an ice climber stands at the edge of a crevasse or a crevice, but I like crevasse. Crevasse sounds cooler. That is 115 feet tall or like deep. The angle of depression from the edge where she stands to the bottom of the opposite side is 52 degrees. How wide is the crevasse? All right, so here's kind of a picture. I guess it's kind of like opposite from how you looked at it. So the ice climbers are standing here looking down at a 52-degree angle. We know, let's change the color of the pen. We know that this is, 115 feet tall. And we're trying to figure out how long the length of AB is. So by using the alternate interior angles theorem, we know that the measure of angle B is 52 degrees. And so we need to figure out what the length of AB is. This is assuming that the crevasse is, the edges are straight up and down and it doesn't like widen out or thin out, going from bottom to top. So if we figure out the length of AB, then we can also figure out how wide the crevasse is. And so we have the opposite side, we need the adjacent side. So we would do tangent of 52 degrees equals 115 over the length of AB. Since AB is in the denominator, we're going to multiply AB on both sides. Boom, boom. So now that it's in the numerator, so that we have AB times tangent 52 degrees is equal to 115. We'll then divide by tangent 52 on both sides so that we get AB by itself. Tangent 52 divided by tangent 52. Whew. This is harder than it looks, guys. I swear. All right, so we get that AB is equal to 115 divided by tangent 52. And whatever you get for that answer is the distance it takes to cross the crevasse, which is useful information in like building a bridge or a rope string or whatnot. All right. The next one is a shipping application. So this is the last one. This one is a little bit more complicated because it's kind of like we're using two different angles of depression. So an observer in a lighthouse is 69 feet above the water. He sees two boats in the water directly in front of him. The angle of depression to the nearest boat is 48 degrees. The angle of depression to the other boat is 22 degrees. What is the distance between the two boats? Round your answer to the nearest boat. Okay, so first, the nearest boat is going to have a greater angle of depression because it's just going to like hit the water sooner, and the farther one's going to have a smaller angle of depression. And so we have to draw this out. And the drawing would look something like this, where we have a boat at A with an angle of depression of 48 degrees and a boat at B at an angle of depression of 22 degrees. And we want to figure out what is X. what is the distance between the two boats? So you might even want to draw a boat and a boat here and a little white house here. Okay? So first, we need to find y. So to find y, we can do tangent 48 equals 69 over y. Okay, that too. For tangent 48 equals 69 over y. And we get that it's approximately 62.1 feet. Now, we don't want to round this yet because we only want to round at the very end. So let's keep it at 62.1 feet for now, and then we'll round at the very end. So now we know that what y is equal to. It's equal to 62.1. feet. Now let's find z, because if we find y, the distance the closest boat is from the lighthouse, and then we find z, the distance the farthest boat is away from the lighthouse, then we can subtract those two distances to find how far apart the boats are from each other. All right, so we know that angle B is a 22-degree angle. So we can do tangent of 22 degrees equals opposite over adjacent, 69 over z. Then we solve for z, which is z is equal to 69 over tangent 22, which is approximately 170.8 feet. So if z was 170.8 feet and y was 62.1 feet, we can subtract those two to find x. And it's approximately 109 feet. So the two boats are about 109 feet away from each other. This is really good to know if you need to make sure that the boats won't collide with each other. All right? And so I said that there was going to be an angle of depression problem that dealt with flying. Apparently, there's not. But you'll see in some of the online quizzes and application that there are some dealing with what is the angle of depression planes go when they are landing, and what is the angle of elevation planes go when they're taking off. So I wish you the best on the online quiz, and I will see you guys soon. Peace out. And remember to travel, explore, and enjoy the thrills and adventures of flying and traveling.